All right, now this is a Unit 1 test. And so if you look in your book and you think about it, Unit 1 is graphing, box plots, and normal distribution. Our test is only going to be on box plots and normal distributions, Chapter 5 and 6. So keep that in mind, because question number 1 and question number 2 really doesn't apply to us. But let's just go through that anyway. We collect data from 50 male students. Which data is going to be categorical? Well, hopefully you realize that that's eye color, okay? Now, number 2 is bimodal, okay? So that means 2 modes. Now, that's not going to be eye color. Head circumference, hours of homework, number of TV sets. The answer is D, and it's because of cigarettes. You get the people who smoke a lot and people who don't smoke a lot. That's my only guess. I never smoked. I don't know. So anyway, D. Anyway, 1 and 2, those kind of questions will not be on our test. Let's go with 3. Which one is more likely to follow a normal model? So by a normal model, we mean we're going to have the distribution of the bell curve, all right? And so this is anything that occurs by nature. So the people who are left-handed, the people who are B positive blood types, all of this stuff is going to be normal distribution. Anything that is man-made, the number of chairs somebody makes, that is not going to be, all right? So follow normal model, the head circumference. Do you see that? Because that is something by nature. Size of your head, okay? The mean number of hours to work for 30 males is 6, and for 20 females was 9, the overall mean. Okay, let's go work this out. I'm going to erase my model because I need the space. Okay, this is what we call a weighted mean. This would be just like if I wanted to find my overall average for AP Stats. I got my A day kids and I got my B day kids. So it's going to be 30 times 6 plus 20 times 9 all over. Now, how many total people do I have? 30 males, 20 females. Is going to be 50. All right, so I'm going to do the math and I'll get back to you. And I get 7.2, so the answer is B. Okay, we might choose to display data with a stem leaf plot rather than a box plot because a stem plot reveals the shape of a distribution, well, so does a box plot. Is better for larger sets. That is not true. Box plots are better for larger sets. And displays the actual data, 3. So the answer is C. Which is true of the data whose distribution is shown. Okay, so do you see how it's skewed to the right? All right, so the function is skewed to the right. That is true. The mean is probably smaller than the median. Well, remember, the mean always goes with the tail. So the mean is bigger, so that is not true. We should summarize with mean and standard deviation. Okay, so you got to remember, this was something that I told you about that was in the book that I didn't teach. If your data is symmetric, it's best to use the mean. If your data is skewed, it's best to use median. So number 3 is not true, so the answer is A. Okay, the standard deviation of the data displayed in the dot plot is most likely to be. All right. Do you see here that we roughly have a normal distribution, right? And my range is going to be 100. Now, how many dots is this? Because I have to go here. So it's going to be 60. So I'm going to turn this off and count my dots. All right, if I count correctly, between 60 and 80, I count 8 rows of dots. Okay, so that's divided by 20. So on my calculator, 20 divided by 8 is I get 2.5. So each dot roughly represents 2.5. Okay, so they want to know the standard deviation of the dot plot is likely to be. Okay, now if each row of dots is approximately 2.5, then this guy is going to be 35. So I need to see how much of my data is represented, so I'm going to find the range, and I get 65. All right, now what do we know about normal distribution? Is that we have 3 standard deviations to the right and 3 standard deviations to the left, and that is 99.7% of my population, which is pretty darn close to 100. So that is a total of 6 standard deviations. Everybody see that? Let me go to another color. I got 3 here and 3 here. It's a total of 6 standard deviations. Well, how much is each standard deviation worth? So 6 standard deviation is equal to 65. Divide both sides by 6. And I get approximately 10 point, what, I think it's like 85. So which of these numbers is the closest to 10.85? And the answer is C. Okay. Okay, let's go down to number 8. And we talk about a normal distribution describes the acidity of rainwater and that the water tested after last week's storm had a z-score of 1.8. Okay, so what does it mean to have a z-score of 1.8? That means that you are 1.8 standard deviations above the mean. All right, and so which one of these is that? Which one of these said that had a 1 point standard deviation higher than the average rainwater? I think the answer for 8 is E. Okay, good. Okay, the ages of people attending the opening show of a new movie are summarized in the ogive shown. Estimate the IQR. Okay, so here is an ogive, and an ogive is essentially a stretched S. Now, in the book, again, they talked about this, okay, with cumulative frequency curves. All right, and so what do we know about IQR? IQR is simply Q3 minus Q1, which is 75% minus 25%. Okay, so let's do, first of all, let's find the median. If I have a total of 100, then the median happens at 50, correct? And remember that Q1 is the median of the lower half. So if this is my lower half, then the median of that is going to be 25. So I'm going to draw a line roughly at 25. And then that means this is my upper half, and my line is going to be at 75, okay? Let me go to another color. So if I wanted to find 25, here's my 25 line. I go to where it hits the curve and I bring it down. And that looks like that's what, 29, roughly? Let's go to my upper here. Hits the curve. Oops. That looks like that's roughly what, 45? Okay, so 45 minus 29. Okay, it's pretty sad. I need my calculator. 45 minus 29, and I get 16. So which one of these guys is closest to 16? Right, and I'm going to say B. Okay, let's go look here at number 10. And searchers arranged, they want to decide if the evidence attempts to produce a trend towards less acidic rainfall. They should display, okay, first of all, less acidic rainfall. Do you see that that's going to be quantitative? So therefore, I'm not going to use a bar graph. All right. And I'm not going to use a table, because it's not a two-way deal. All right, now here we're taking stuff on a daily basis, okay? And so that's why E, the time plot, would be best. But again, that was from last time. That kind of question is not going to be on the test.